Welcome to today's webinar, What's New in ThreatMapper 1.2. It is my pleasure to welcome you to today's presentation and to introduce your first speaker, Owen Garrett, Head of Products and Community here at Deepfence.
Thank you, Michelle, and thank you everyone for joining today's webinar, where we'll go through a quick run-through of some of the new capabilities and features that we brought in the ThreatMapper 1.2 release, and we'll finish with a little touch on the future direction for ThreatMapper. All the way through, if you have any questions, as Michelle mentioned, please don't hesitate to drop them into the Q&A box, and we'll pick those up either during the webinar or in a Q&A session at the end. I hope this time will be useful for you as we go through some of the new capabilities that ThreatMapper provides. Many of you, I hope, will be familiar with Deepfence's ThreatMapper open source product. But for those who aren't, let's just take a little bit of a background as to why ThreatMapper exists. ThreatMapper exists because vulnerabilities in products that enterprises and individuals build are critically important to understand and address. There's been lots of investment in shift-left approaches. It's a well-served process with a range of open source, as a service, and commercial solutions that are targeted towards developers and help developers be confident that the code that they push into production is free from known vulnerabilities. New applications can then avoid vulnerable modules such as older Log4j or struts modules, or operating system builds can avoid vulnerable packages. This is a well-served process. Lots and lots of innovation, many options and opportunities there to help you build applications that you can be confident are secure. But shift left only deals with half of the security problem of securing and tracking vulnerable applications. And a lot of the capabilities that the app security team need have been left behind. The secure right is not as well advanced as the shift left. And secure right is important. New vulnerabilities are published daily. Just because an application was built and passed all of the shift left scanning solutions 2 weeks ago does not mean that it's still free from vulnerabilities. Late breaking issues give enterprises the need to scramble and audit their existing applications to determine, are those applications vulnerable to those late breaking issues? A lot of production applications don't have a software bill of materials. Either the internal processes don't go that far, or indeed those applications could be third-party apps, plugins, agents, even bits of infrastructure. It's difficult without an accurate software bill of materials to understand what is present in the applications, the containers, and the workloads that you're running. And indeed, has someone already compromised those applications? Is an attacker already roaming through your infrastructure, taking advantage of vulnerabilities, gaining initial exploits, establishing a beachhead, and spreading laterally? The reality is that shift left is not the last word in securing production applications today. It's a really important step in ensuring that applications that are pushed to production are as secure as possible. But application security teams commonly report that production is out of control. They don't know fully what's running in production. They're confident that vulnerabilities exist, but they don't have a way of identifying those vulnerabilities or indeed determining whether those vulnerabilities pose a real and present risk to the application. And that's the problem that Deepfence ThreatMapper sets out to solve. ThreatMapper brings 3 core capabilities. It allows you to interrogate your runtime infrastructure to discover the hosts, the containers, the workloads that are running on a local environment, on remote clouds, and across multiple clouds, supporting containers, Kubernetes, Docker, Fargate as a feature in 1.2, and of course, bare metal and virtual machine workloads as well. ThreatMapper solves the first problem of discovering what is actually running in your production environment. And it learns the topology of those applications for reasons that will become really clear as we look at some of the new capabilities. Having discovered the workloads that are running in your environment, ThreatMapper then deals with the challenge of building a bill of materials for those workloads. The SBOM may not exist, but ThreatMapper is able to interrogate the running workloads and determine what components make those workloads up: operating system packages, language packages, other dependencies. ThreatMapper will scan those and then match those against over 50 different threat feeds in order to determine if your containers and hosts and workloads contain vulnerable components. And it's not uncommon in even a small-sized environment to find thousands of reported vulnerabilities in the workloads that have been deployed. How do you deal with those thousands of vulnerabilities with varying degrees of severity and criticality? That's the third thing that ThreatMapper brings to you. ThreatMapper then matches the vulnerabilities with the attack surface that it's learnt from your applications. And it ranks those vulnerabilities based on the risk of exploit for each of those, their proximity to the attack surface, the existence of network connections, building the attack path to show you how an attacker could potentially reach that vulnerable component. If necessary, hopping through multiple stages, load balancers and proxies. What's new in ThreatMapper 1.2? We released ThreatMapper as an open source project in October last year. 1.2 was released about 10 days ago. And 1.2 brings a number of new capabilities to you. It brings the attack path visualization that we saw on the previous slide. The attack path visualization delves deep into the attack surface and identifies requests as they move through your infrastructure to identify workloads that are open to traffic from outside, even if they're behind multiple layers of proxies. This attack path visualization then gives you the confidence to understand why ThreatMapper is prioritizing particular vulnerabilities as being at a high risk of exploit. Secondly, we've migrated across some capabilities within the Threat Striker product, as we'll continue to do in the roadmap for ThreatMapper. In this release, we've added support for Fargate workloads, meaning that from a single console, from the ThreatMapper management console, you can track a very wide range of production workloads, containers running in Kubernetes or Docker, virtual machines, as we said, and now also Fargate workloads, all from a single pane of glass, giving you a coordinated view of the assets that are deployed and the threats to which they may be subject. We've built out the integrations. We've added integration with Google Chronicle, an emerging SIEM solution based on BigQuery that can process vast quantities of security-related data. Now, ThreatMapper, as you'll see, can push vulnerabilities and user activity out to Chronicle for offline analysis and archiving. And finally, one of our community members experimented with our open source solution and published an update that allows you to run the ThreatMapper sensors on ARM platforms. So whether you're running on AWS on their new Graviton processors, or indeed if you're running edge devices, IoT or edge devices based on ARM technology, you can now use ThreatMapper to monitor and to secure those devices as well, building a much more complete threat map of the attack surface and the vulnerabilities that your application and solutions may be subject to. Behind these key headline capabilities, we've made tweaks and improvements to the most exploitable vulnerability calculation that we use, adding more weight to the proximity to the attack surface. This drafts off the attack path work that we've done, and weight to services that have active network connections. We fixed some limitations and improved our support for Kubernetes and containerd environments, making it even easier for you to scan entire Kubernetes platforms with a couple of clicks. ThreatMapper doesn't just scan runtime environments. You can also use ThreatMapper to scan pre-production assets. For example, you can point ThreatMapper at your registries, and we've provided better feedback and improvements on how ThreatMapper can index and scan containers sitting in the registry before they're deployed. And of course, many updates and improvements to the user interface and the user experience. Let's see ThreatMapper in action, just very quickly. We begin with the classic topology visualization that ThreatMapper gives you, from a single pane of glass showing you all of the workloads that you have running, whether these are Fargate workloads, whether they're running an ARM as edge workloads, or indeed traditional classic Kubernetes workloads as well. And you can click through these as ever, understanding what is present and tracking, performing vulnerability scans, looking at the vulnerabilities that were detected against different assets. We've improved and extended the amount of information that we provide for individual workloads, additional metadata to help you identify and track down when we flag up issues with particular workloads. And then with vulnerabilities, as ever, you can go through and look at your vulnerability scans to identify what has been found. As here, we've looked at a couple of registry images, and then we go and look at some more recent images with some issues. So we can click through and see the particular issues that ThreatMapper has found, but the strength really comes from the most exploitable vulnerabilities report that we see. Here, from a single pane of glass, ThreatMapper is showing you what we have calculated to be the vulnerabilities that pose the greatest risk to your applications and infrastructure. And we show the attack path, how those vulnerabilities, individual vulnerabilities, can be reached. In some cases, you'll see these behind multiple tiers of load balancers and proxies. The attack path shows into sharp relief why it is so important to fix those particular vulnerabilities, the ease of access that an attacker might have in order to explore with recon traffic and then exploit with weaponization traffic those particular vulnerabilities. Some improvements to how the registries are displayed, allowing you to more easily track what's in the registry, perform a scan, and monitor the progress of those scans. And as we mentioned, support amongst our many integrations for Google Chronicle. Very straightforward to set up, and we can push vulnerabilities or user activity towards Chronicle. You can filter that based on individual Kubernetes clusters or namespaces to send that data to the correct location in Chronicle for offline analysis. What's coming next in the ThreatMapper project? Software vulnerabilities are not the only risk that your cloud native applications face. Unprotected secrets, API keys, passwords, authentication tokens, those can sometimes find their way into containers, into workloads, onto hosts inadvertently. It's very easy to overlook those. And an attacker who gains sufficient access to one of those workloads may then be able to locate such secrets and use those to spread laterally. Deepfence has a secret scanner, open source project. It's a very popular little tool, command line tool that can be run to scan environments, and we'll be integrating the secret scanner technology into Deepfence ThreatMapper. So again, from a single pane of glass or behind a single API, you'll be able to trigger scans for secrets on your hosts, your containers, and against your registries, looking for sensitive data. And in a future release, we'll extend that further with a range of compliance benchmarks, NIST and Kubernetes benchmarks that can run against system and infrastructure services to look at the configuration and match that against best practices, identifying misconfigurations and other potential security issues. You'll see this these scanning capabilities coming in ThreatMapper over the next few months. Secret scanning coming soon and compliance following. What you can't see, of course, you can't protect. And there are many opportunities for us to focus on how the data that ThreatMapper is able to gather is presented. Pivoting it and slicing it based on particular views. What virtual machines are at greatest risk? What secrets are most exposed? More data on serverless and Lambda environments. And providing additional visualization to cover not just vulnerabilities, but also the use of secrets to potentially spread laterally. There's a lot of research going on within the Deepfence team to determine the best ways to provide this kind of information and present it to you so that you're able to understand and identify the most significant risks that your infrastructure faces, so you can step in and fix those as promptly as possible. Deepfence ThreatMapper is part of a suite of technology that allows you to look at and secure your production infrastructure, and then to track the behaviors that an attacker may make, identify the subtle signals and step in, correlate these behaviors, respond and protect. The core of the technology, the ThreatMapper, the ThreatMap capability, is entirely open source, and all the Deepfence technology operates in out-of-band fashion with a very light footprint, multimodality supporting multiple different types of workloads and across multiple clouds. If you'd like to find out more about ThreatMapper open source, please head across to GitHub, find us at Deepfence/ThreatMapper. It is a straightforward get and compose to install the management console, and then following that, different ways to deploy the Deepfence sensor agents, depending on your production environment. Give it a go, and if you have any questions, if you need any help, reach out and find us in Slack at Deepfence. So with that, I hope that's been a helpful update on some of the capabilities that have come in ThreatMapper over the last couple of months, and a little bit of a look forwards as to the capabilities we'll be adding over the following few months. So thank you very much for your time. I'll take a quick pause now. There may be a few questions, which we're happy to deal with. So Michelle, I'll pass across to you, and I've got a question for Sham when we're ready as well.
Awesome. Thank you so much, Owen, for presenting the new capabilities and features in ThreatMapper 1.2. And with that, we are now taking questions. If you have any questions, please use your Q&A box at the bottom and go ahead and type in your question. You can type your question in anonymously, or you can not check anonymously and your name will be attached. And with that, there is one question here. Sham and Owen, do you want me to read it aloud and then one of the two of you can answer it?
Yeah, please share it so everyone can see.
Okay. How difficult is it to maintain the agents that ThreatMapper uses?
So Sham, do you want to take that one?
Of course, Owen, I can take that.
Yeah.
So hey, everyone. So from a maintenance perspective, deploying the agents is as simple as putting in a daemon set if you're using a Kubernetes cluster, or deploying a Docker container if you're using systems that have Docker installed in them. Once that is done, it's a one-time process. Even the upgrade of the agents can be done through the management console itself. So from a maintenance perspective, you can think of the agents as an invisible monitor and data collection process, or a data collection daemon set that resides invisibly, and which is not a proxy, it is not inline, it is not a kernel module. So there is absolutely no impact whatsoever to your existing workloads. So it's easy to install and practically maintenance free. I hope that answers the question. Feel free to post additional questions on the Q&A box.
Sure, thank you, Sham. So the agents, deployed as a daemon set in Kubernetes, as directly on a Docker environment, and we will be ensuring that there's forward compatibility and backward compatibility as far as possible between the agents. As we version control the ThreatMapper software, we will include a matrix or a commitment to that the ThreatMapper management console will interoperate correctly with various versions of the ThreatMapper agents, because of course it's not always practical to update both at the same time. Okay, I had one question for you, Sham, if you don't mind. We saw the attack path visualization and how that is able to not just identify workloads at the edge of your infrastructure, but also see through intermediary proxies and load balancers to identify workloads that can be reached directly from outside. Could you share a little bit technically about how we managed to do that?
Yes, perfect. Yes, I will. So as Owen just spoke about it, it is not just that we Deepfence are able to look at your attack path on the edge nodes. We can also look at attack paths for the nodes that are deep within your infrastructure, that are on seemingly air-gapped environments. The theory here is that typically when you get a request on any edge-facing network, that request does not stop at that edge-facing system. It usually moves over to be serviced from a different system. A classical example is your external facing front end of any application and a database that's put in behind that front facing application. So typically the chain is you have one server or one system that is used for the customer facing application and another system that's used for the database. And these two communicated each other or simple network, right? Now, it is possible that the system where you have your database has vulnerable libraries. Deepfence, by the virtue of having the sensors deployed across your infrastructure, is able to analyze these connections, the flows between these connections, and able to build a network traffic map of your entire infrastructure. That gives us a very unique insight into being able to understand the flows, even if they occur multiple layers deep within your infrastructure. And this also gives you a very, very unprecedented visibility into your entire infrastructure, where when you assume that certain systems are multiple hops behind your internet facing system, it actually is reachable and Deepfence will illuminate those blind spots for you. I hope that kind of brings in some clarity to the thought process, Owen.
Yeah, thank you. Thanks, Sharon.
No problem.
Owen, Sean, that concludes the questions that we have so far in the Q&A box. Any closing comments about ThreatMapper 1.2 or other Deepfence happenings before we close out?
Well, I just want to close with, I hope that you're inspired with the work that we're doing here in the Deepfence team, led by Sham, to build out a security solution that will help you secure your production applications. There's a lot of exciting stuff going on. Please do head across to GitHub, deploy, experiment with it, share any bug reports as issues. We'll happily take those on board, and any code contributions or feature suggestions are really welcome. So thank you again for your time.
I would also like to add, please do join us on our Slack channels, and you can hang around the announcement channels, and that will give you a ringside view into what's coming up next.
Awesome.
Thank you, everyone.
Thanks. Thanks to everyone who joined today and to today's presenters. And with that, we'll officially close today's session.
Thank you, everyone.
Thank you.
Thank you.